In this lesson, we are going to talk about the correlation coefficient. When doing least squared regression, the first thing you want to do is to look at the data through a scatter plot to see if you think that a linear relationship exists between the two variables or is reasonable for the two variables. If you determine that a linear relationship does exist between the two variables, the second thing you want to do is calculate the correlation coefficient. The correlation coefficient is a numerical summary that gives the strength and the direction of the linear relationship between the two variables. So let's take a look at that. The correlation coefficient is also called the Pearson product moment correlation coefficient. That's a mouthful, so I'm just going to call it the correlation coefficient. It is a numerical measure of the strength of the linear association between two quantitative variables. If there is a quadratic relationship between the two quantitative variables, the correlation coefficient will not tell you the strength of that relationship. The correlation coefficient only tells you the strength and the direction of linear relationships. What do we use to designate a correlation coefficient? We use a small letter r. That designates the correlation coefficient. How do we calculate the correlation coefficient? We first start with our n data points that we graphed in a scatter plot to look at the data. For each of these data pairs, we standardize the x data and we standardize the y data, and we take the product of those two standardized values. So let's look at the formula for the correlation coefficient. Forget about the constant out in front. For each data point, we want to standardize the x value. How do we do that? We take the x data, x1, we subtract the mean of all of the x's, and we divide by the standard deviation of all the x's. We do that for the y data. We take our y value, we subtract the mean of all the y data, and divide by the standard deviation of all the y data. In other words, we standardize the y value. We take the product of those two numbers. We do that for each data point, add them all up, and ultimately divide by n minus 1, where n is the number of data points. That is how you calculate the correlation coefficient. You standardize an x value, multiply it by its corresponding standard y value, do that for each data point, add them together, and divide by n minus 1, gives you your correlation coefficient. What are the properties of our correlation coefficient? The correlation coefficient is always a number, a real number between -1 and +1. A correlation coefficient equal to -1 means there is a perfect linear relationship, and it is negative, a negative slope, a perfect negative relationship. A correlation coefficient of +1 means there is a perfect positive linear relationship between the two variables. The sign of r determines the direction of the association. Positive values of correlation coefficient means there's a positive relationship, positive association between your two variables. A negative correlation coefficient means there's a negative association between the two variables. What does a positive association mean? A positive association means that as x increases, y increases. A negative association means as x increases, y will decrease. The magnitude of r determines the strength of the linear association. The greater the absolute value of r, the greater the strength of the linear association. Remember we said if the correlation coefficient was equal to 1, it was a perfect linear relationship. The closer r gets to 1, the stronger the linear relationship is. R is a unitless measurement. It does not have any measure. When we standardize each of the data values, those are unitless measures. And the last property is that you do not need to identify a variable as an explanatory variable and one as a response variable when calculating the correlation coefficient. When you do a regression, you must identify one of your variables as explanatory and one as response. It does not matter when calculating a correlation coefficient. If we would reverse, and instead of doing a scatter plot of xy, we did a scatter plot of yx and calculated the correlation coefficient, they would be identical. So it does not matter which variable is explanatory and which is response when calculating a correlation coefficient. In recap, the correlation coefficient measures the strength and the direction of linear relationships between two variables.